On September 5, 1977, a small spacecraft left Earth carrying more hope than certainty. It was called Voyager 1. At the time, it was not seen as extraordinary. It was part of a carefully planned NASA mission designed to study the outer planets of our solar system, Jupiter, Saturn, and their many moons. The mission had a clear structure, a limited timeline, and an expectation of short-lived success. No one involved in its launch imagined that it would still be active nearly half a century later. Voyager 1 was built using technology that, by today's standards, seems almost primitive. Its onboard computer has less processing power than a basic digital calculator. Its systems were designed in an era when deep space was still largely theoretical, and long-term survival beyond the outer planets was not part of the plan. It was meant to observe, collect data, and eventually fall silent. But Voyager did not stop. It passed Jupiter, revealing violent storms and dynamic atmospheric systems that had never been seen before. It moved on to Saturn, capturing detailed images of its rings, uncovering their complexity and structure in ways that reshaped planetary science. These discoveries alone would have secured its legacy. But its journey was only beginning. After completing its planetary observations, Voyager 1 continued outward, carried by momentum into the farthest regions of the solar system. Years turned into decades. Systems aged. Instruments slowly degraded. Yet the spacecraft persisted, sending back faint signals across billions of kilometers of space. In 2012, it reached a threshold that had never been crossed before. Voyager 1 entered interstellar space. This region lies beyond the influence of the Sun's solar wind. It is not a boundary marked by walls or edges, but by a gradual shift in the environment, a transition from the Sun's controlled influence into the wider galaxy. For the first time in history, a human-made object was no longer inside the solar system. It was drifting between stars. Even there, Voyager 1 did not fall silent. It continued transmitting, though its signals were faint, delayed, and increasingly fragile. Each message takes hours to reach Earth, traveling across unimaginable distances before being captured by the Deep Space Network. And yet, those signals still arrive. Inside them, scientists find measurements of the interstellar medium, the sparse environment between star systems. It is not empty, but incredibly thin, filled with charged particles, weak magnetic fields, and radiation that has traveled for millions of years. Voyager 1 became humanity's first direct probe of this environment. And what it revealed was not entirely expected. Occasionally, its instruments reported sudden spikes in particle density. Plasma wave activity appeared more complex than models had predicted. Magnetic field measurements shifted in subtle ways that did not always align with theoretical expectations. At first, these irregularities were attributed to known factors: instrument aging, calibration drift, or natural turbulence in interstellar space. But as more data accumulated, patterns began to emerge. Not random ones, but structured ones. Voyager 1 is not a powerful spacecraft. It operates using a radioisotope power system that slowly decays over time. To conserve energy, NASA has shut down many of its instruments. Only essential systems remain active. Despite this, the spacecraft continues to function with remarkable stability. It operates in temperatures approaching near absolute zero. It endures radiation that would destroy most modern electronics. It communicates across distances so vast that even light itself takes hours to complete the journey. And still, it works. Another important discovery came from studying the heliopause, the boundary where the solar wind loses its strength and the interstellar medium begins to dominate. This boundary is not fixed. It shifts in response to solar activity. When the sun is more active, it pushes outward. When it is quieter, it contracts inward. Voyager 1 revealed that this region behaves more like a dynamic interface than a solid edge. It is a breathing boundary between the solar system and the galaxy. In addition to its scientific instruments, Voyager 1 carries something symbolic, the golden record. This phonograph disc contains sounds from Earth, natural environments, human greetings in multiple languages, and selected pieces of music representing human culture. It was designed as a message in case the spacecraft is ever encountered by an intelligent civilization. It is both a scientific artifact and a cultural time capsule. A silent introduction to Earth, drifting endlessly through space. But beyond its symbolic meaning and scientific data, Voyager 1 has revealed something more subtle, unusual behaviors in the data itself. Some plasma wave recordings, when converted into sound, reveal patterns that repeat in ways not fully explained by current models. While most scientists interpret these as natural interactions between charged particles and magnetic fields, others continue to study whether deeper structures might be present. In environments as vast and unpredictable as interstellar space, even simple phenomena can produce complex results. And complexity often looks like intention, even when none exists. Voyager 1's continued survival has also inspired new generations of space exploration. Engineers and scientists now look beyond traditional spacecraft design, exploring concepts like miniature interstellar probes and laser-driven missions that could one day travel to nearby star systems. Voyager proved something fundamental: long-term deep space exploration is possible. And more importantly, it is sustainable. Its earlier discoveries already transformed astronomy. It revealed volcanic activity on Jupiter's moon Io, showing that it was one of the most geologically active bodies in the solar system. It uncovered the structure and motion of Saturn's rings. It helped redefine our understanding of planetary systems entirely. But perhaps its most iconic contribution came when it turned its camera home. From billions of kilometers away, Voyager 1 captured an image of Earth, a tiny, pale blue dot suspended in a beam of sunlight. In that moment, everything humanity had ever built, fought for, or dreamed of existed within a single fragile point of light. That image became one of the most powerful reminders of our place in the universe. Today, Voyager 1 continues its journey outward. Its systems are aging. Its power is fading. Its transmissions grow weaker each year. But it continues to move forward into a region no human-made object has ever reached before. More than a machine, it has become a symbol. A symbol of persistence. Of curiosity. Of humanity's willingness to reach beyond what it knows. Every faint signal it sends is not just data. It is evidence that exploration does not end when a mission timeline expires. It continues as long as something still moves forward into the unknown. And as Voyager 1 drifts deeper into interstellar space, it carries with it a simple truth. Even the smallest object, built with limited tools and imperfect knowledge, can travel farther than anyone ever expected, and still speak back across the darkness.